In this video we'll be seeing how concurrency actually works, and with an example in Go. I'm choosing Go because Go has like built-in packages for concurrency maintenance. So we have the sync package, which is very useful in Go, and so we'll be using that. So before even going into the implementation, we can just see how concurrency works and what's how Go actually maintains it. So the first diagram I would like to get started with is this. So this is like a traditional function without concurrency. So what would happen is, let's say we have two functions, func1 and func2, and func1 main function calls func1 and func1 calls func2. So this will be waiting here when the main function calls func1. The line at which the func1 is called, it would be waiting for some response, and func1 in turn calls func2, which will in turn be waiting for some response. So when this get backs, it's like if you know how functions work, like they put the functions into a stack and then just pop it as they go. So that is how traditional functions work. This line is the lifetime of main, and when it goes, it just calls func1 and continues its work. So it's like just calling, or you can say Go or any other language which concurrently calls this function uses a thread to invoke this function and assign this function to that thread, and it in turn creates another thread for some other function, and so on. So we need, in order to maintain or use the results that we gain from these functions, we need to use some kind of maintenance, or you could say locks, if you technically ask. So we need to lock some things in a way such that all the responses are sequentially stored and are in a correct order, because we don't want some result from function 2 even before the function 1 result gets in, because if they are interconnected. So that doesn't make sense, because we need to use the function 1 and function 1's data using function 2. So it's interconnected, so we need to figure out some way or use some technicalities to maintain the order of things. In Go, there is something called Go routines, and there is WaitGroups and Mutex. We'll be getting into that. So Go routine is just a function, nothing more than that. But when you put, when you say instead of function, when you say Go function, it just means that run this function in a separate thread. I have a sample program here. So let's say we have some function func1, then you can say Go func1. So that just calls the Go function, but it just invokes, it creates a new thread for this function. So that's how we use concurrency in this Go. And we have something called mutex. If you have heard of, or if you have taken the OS class in your college, then you might have heard about mutex and locks. So we have something, let's say we have something called mutex and WaitGroups. So here, like let's say main function is taking about 2 seconds to finish, and this function takes 5 seconds, and this function 2 takes 3 seconds. Then the main function should wait for these functions to complete, even if main has done everything below these function calls. So it has to wait for these functions to complete. So it should not end the program right away. So we'll see that using what's the reason we need WaitGroups. So let's see that using a simple function. So let's say func hello, and in this function just says hello. Let's say println hello. Now when I call this hello function and I run this, go routines 3.go, it calls, because this is a simple function call and we call the function. But what happens if I go with a Go routine instead of a usual function? Nothing happens, because we are not waiting for this function to even give the result out, right? So because we are calling Go, it invokes a thread and then the main function finishes. So we are not saying it to wait, or at least wait until this program even starts or finishes executing. We just say run this thread and that's it, nothing else. So that's the reason we are not getting any output, because we are not even waiting for this function to complete. So there's a little hack for this. So you can wait for 1 second or so. So you can sleep, like you'd say time.sleep 1 into time.second. So what this means is that you can sleep for 1 second. So in this 1 second, this hello function is invoked, because we believe that this takes very much less than 1 second. So it is true, and this function gets invoked in that time. It sleeps, and in this time the function is this function finishes executing and uses as this result. So but in production grade applications we don't want to use this sleeps, because we don't know what we need proper technique to do this, and other than randomly calling the sleep function. So we don't want to use sleep. So that's where these wait groups come. So wait groups allow you to wait for some function to end. So a simple example would be, we have to first declare the wait group here. Let's declare that globally. Let's say where wait g is of type sync. This wait groups is in sync package. So we'll say sync.waitGroup, and let's just import. And so even before having this calling this go function, we need to tell this wait group how many go routines we are going to use. So we need to say that using waitg.add of 1. We are adding 1 because we are saying there's only one go routine, just wait for 1. So we add 1, and here, and let's see what happens now. We have added 1. So nothing happens because we are adding it, but we are never telling the function that this function has finished, right? So we have to give an kind of an acknowledgement that this function has finished executing. So you could say waitg.done to finish executing this, so that it invokes, or it acknowledges the wait groups, so that the main program waits. And we are saying done, but there is still something left. We need to call wait group dot wait, so that, and you can see, I think there's a little bit of documentation here. So see, wait blocks until the wait group counter is 0. What they do mean by that is that we have added 1 here. We have initialized the counter to 1. When this done is done, it just decrements the counter, so it becomes 0, and this waits until it's 0. So whenever you call is done, then it's done, that's it. So it stops waiting. So let's now run this, and you can see we are getting hello now, because it waits till this finishes this execution. Take this done and put it above this function. Let's see what happens. So it's not printing anything because we are just saying done, and as soon as it says done, then this stops waiting and goes below. So it just stops, the main function stops executing. So that's it. So one thing to make sure that we are doing always, at the end of this function, is to use the defer keyword in Go, so that even if it's in the top of the line, it just executes whenever the function is going to end. So now we can run this, and you can see hello is being printed. So now we know what wait group is. So let's move on to some more challenging stuff. So let's remove this hello and wait groups. So I want what I want is I want some function to, I want to have a counter, and I want this hello function to say hello 1, hello 2, hello 3, and so on. So for that we need some counter. Let's say counter, and let's initialize it to 0, and let's have another function. Let's say increment. In this increment function, what we do is we just increment this counter. That's it. And in this hello function, what we say is we just print the value of the counter. Let's say printf hello, and let's say the counter. And let's put a new line here. That's it. And I want this to happen like for 10 times. So let's run a loop. And first I want to call hello, and then I want to call increment. So let's see how this goes. So it goes fine because we are getting everything in order. Now I want to do this as a go routine. So I put go in front of them and I just run this. So okay, I think we know the reason why this isn't happening, because we are not waiting for these functions to complete, right? So let's do what we have done earlier. We have the wait group, and let's say wait group dot add 2 this time, because we have two go routines. We need to add 2, and we need to add 2 not at the start of the function but at every time this loop restarts, or for every iteration of the group I want to add 2 wait groups, or you can say 2 for the wait group. And whenever this function completes, I want to say wait group dot done, and similarly I want to say here, and the final statement would be wait group dot wait. So this let's see now what the output looks like. So this is kind of weird, because you can see we are not getting the exact order, because the counter is 0 but it's not in the order of 1 2 3 4 so on. We have 3 2s, 5 6 7 8 9 and 2 10s. So this is definitely not the order we need. What might be the reason for this? I think if you have guessed it right, like we are using the counter variable here, and also we are using incrementing. I mean, you could say we are reading the counter value here in this hello function, and we are writing it here. So if you have seen this diagram, we have these two functions running it concurrently or parallelly. We don't know when this function is writing, and we don't know when this function is reading or writing. So we have no idea which variables are being written or read. So you have to make sure that whenever some function is writing to some variable, no other function is reading, and whenever some function is reading, no other function is writing. So to do this, we have to use mutex logs. So what we do is, whenever before writing, we lock the variable so that anybody does not read, and before reading we lock it so that anybody don't read. So yeah, so let's initialize that. Let's say mutex is equals to sync dot mutex. Let's say rw mutex. Let me so in this locks, like we need to lock this variable, right? This mutex, we can lock and unlock it. So there are some different kinds of locks, like there is read lock and there is just lock. With rlock, multiple go routines can read multiple reads, which means multiple go routines can read at the same time, but only single write. Only one go routine can write at a given point of time. With lock, only one go routine can either read or write. Before calling this hello, we need to lock the variable so that any other function does not write to it. So as we see in here, we have multiple reads but only single write. So we'll use the rlock here. So you could say mutex dot rlock. So we have rlocked it so that in this function the variable the mutex variable is locked. So we have to unlock that similarly in this function. So let's go to the end of the function and let's say mutex dot r unlock. So we have to make sure that we are doing r unlock and not the normal dot unlock, because we have locked it with read lock. So we have to unlock it as read unlock. So similarly we'll go below this, and below increment we are going to do, so we're doing lock because single read or write. We don't want any other we could say any other functions to read this mutex variable when we are writing to this, right? So we lock this, and similarly we go here and we just say mutex dot unlock. So let's try this. Okay, we have getting the order every single time. So we would say that order is strictly in an increasing order and also sequential, because we have asked it to. So a brief overview of this is that we have used mutex logs, and also we have used wait groups. We use wait groups to wait for every go routine to finish, and we are using mutex to control the use of variables, because we are using a global variable here, we want no other go routine to read when we are writing to it, and we want no other go routine to write when other go routines are reading it. So we just lock it here. So before reading it, there's a go routine hello which only reads the counter. So before reading it, we just read lock it, so that many go routines can read it, but no one can write to it. And then we unlock it here. We do an R unlock, and later after this, before the increment, before we are writing to this variable, we just lock it. So lock is different from rlock because lock does not prevent any other function to read or write when we have this lock attained. So here we write to that variable and then we just do unlock. And above this we also do wait g.done because we want to say that no need to wait no more. So we can just put it below this because we want that to happen the very last, or you can say defer. So that's how concurrency works in Go. Not only Go, you can use this type of locks in Go, but this is how concurrency is attained, you could say. But yeah, this is what I wanted to show. Thank you for watching, and do subscribe and like and share this video. Thank you.